Explained and unexplained variation. Assume that we have a sample of paired data having the following properties. There is sufficient evidence to support the claim of a linear correlation between x and y. The equation of the regression line is 3 plus 2x. The mean of the y values is given by the following equation. The mean of the y is equal to 9. One of the pairs of the sample data is x equals 5 and y equals 19. The point 513 is one of the points on the regression line because substituting x equals 5 into the regression equation of 3 plus 2x yields the following, which it gives you 13, because 3 plus 2 times 5, 2 times 5 is 10, plus 3 gives us 13. So what we want to do is we want to go on a graph and determine the total, the explained, and the unexplained deviation. So the first thing we would do is we would need to graph the regression line. So here is our regression line. And so I've already graphed it here for you on the graph. And this line that's in red represents the regression line, which is 3 plus 2x. Okay? And then we also have the graph of the mean of the y values, which represents that. So this blue line here represents the line of the mean values of the y's, which is equal to 9. So now we want to come back up here and see here. It says one of the pairs of the sample data is 5, where x is 5 and y is 19. So we're going to go ahead and plot that on the graph. So when we look at here, we come across here where it says 0, here's 5, and then we're going to go to 9. So there's 19, excuse me. We're going to go to 5, 19. So here's 5, and we're going to go all the way up here. So this point right here is going to represent 5, 19. Okay, and again, this is one of the pairs of the sample data. Now the point 513 is one of the points that's on the regression line. So 513 is right here, and it's right on the regression line. Okay. So since we have 5 here, we also know that 5 and the value of 9 is going to be right here. So right on the mean values of the y, we know that this point 5, 9 is going to be there. Okay. What we want to do is we want to determine what is the total deviation. Well, the total deviation starts from the y value for this point here where it says 519 all the way down to the mean value of 9. So this right here is going to represent the total deviation. So to find the total deviation from the mean of the y values, which is equal to 9, of the point 519 would be the following. You would take the value of y, which is 19 up here. So you take the value of 19 of the y value and then subtract the mean of the y's. So 19 minus 9 equals 10. That means that the distance, so from here, this represents y minus this value. And again, that's 19 minus 9, which is equal to 10. So therefore, the total distance from here to here is 10. Okay, now the next thing we want to do is we want to determine the explained deviation. Okay, now the explained deviation is from the actual regression line, the point here, to the mean value of 9. So this here is going to represent the explained deviation. Okay, now since that point is on a line, that value of 13 represents the predicted value, and then we're going to subtract the mean of the y values. So here, in order to find that value, we're taking the predicted value of the y, which is 13, and then we're going to subtract the value of the mean value, which is 9, and that gives us 4. Now that represents the explained deviation. So you can see here that this is the line that's below here to the value of 9. That represents the explained deviation. Now the last thing we're going to do is look at the unexplained deviation. So the unexplained deviation goes from 519 to the value of 513. So this represents the unexplained deviation. So as you can see here, that means we're taking the value of y, which is 19, and then we're going to subtract the the regression or the predicted value of that y, which is 13. So here you can see that we take value of y, subtract the predicted y value, so 19 minus 13. So we take 19, subtract 13, and therefore that gives us 6. So that explains the difference between a total deviation, the explained deviation, and the unexplained deviation. So here's a formal definition. Total deviation. What you do is you assume that we have a collection of paired data containing the sample point xy, and that the predicted y value of y obtained by using the regression equation, and that the mean of the sample y values is y bar. Now, the total deviation of xy is the vertical distance from that y value minus the mean value of the y's, again, which is the distance between the point xy and the horizontal line passing through the sample mean, which is what we did here. And the explained deviation is the vertical distance from the predicted y value minus the mean value of the y's, again, which is the distance between the predicted y value and the horizontal line passing through the sample mean of y bar. And then the unexplained deviation is the vertical distance from y minus the predicted y value, again, the distance between the point xy and the regression line. The distance y minus the predicted value is also called a residual. So therefore, the total variation is going to equal the explained variation plus the unexplained variation. Now, if we had a bunch of data values, we would then want to find the total variation, which is the sum of all the y minus the mean values squared, and that's going to equal the sum of the predicted y value minus the mean of the y value squared plus the sum of the value of y minus the predicted value of y squared.